Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 14 video on the chapter of rational numbers where I will solve the sample test paper number 2 on the chapter rational numbers. In the previous video in part 13, I solved the sample test paper number 1 on the chapter of rational numbers. If you have not watched that video, I strongly suggest that you watch that video, try to solve the sample test paper number 1, and if you are stuck at any problem, then you see the solution video in part 13. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author R.S. Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have the question paper, sample test paper number 2 on the left hand side, and on the right hand side I will solve the problems. It is recommended that you first try to solve the problems yourself a couple of times, and if you cannot solve it and if you are stuck, then you can see the solution, this solution video as a reference of the solution. And while I am solving the problems, you can pause the video and take a screenshot of the solution for your future reference if you think it will help you. Okay, so let's start solving the problems. Problem number 1 says, find the additive inverse of the non-zero rational number p by q such that 2 by 9 multiplied by multiplicative inverse of p by q equals to minus 3 by 4. Find the additive inverse of the non-zero rational number p by q. Okay, so we have the given equation is 2 by 9 multiplied by the multiplicative inverse of the rational number p by q is equal to minus 3 by 4. Okay, from here we can say that this implies p by q minus to the power minus 1, that is the multiplicative inverse of p by q will be equal to so the coefficient of coefficient of the multiplicative inverse of p by q on the left hand side is 2 by 9. So when we find p by q, multiplicative inverse of p by q, we will need to multiply the coefficient. We will need to multiply the multiplicative inverse of the coefficient with the right hand side. So we have this. Now this is equal to multiplicative inverse of 2 by 9 is 9 by 2. This is multiplied by minus 3 by 4. Okay, and this is equal to minus 27 by 8. So we have the multiplicative inverse of the rational number p by q is minus 27 by 8. So this implies p by q will be equal to the multiplicative inverse of p by q. So when you take the reciprocal, multiplicative inverse and reciprocal are the same thing. So the reciprocal of a rational number p by q is the rational number p by q itself. So p by q will be equal to, then we know that the multiplicative inverse of p by q is minus 27 by 8. So we have minus 27 by 8, its multiplicative inverse or reciprocal. Now this we know is 8 by minus 27, and the denominator is negative, so we have to make the denominator positive, so it becomes minus 8 by 27. So the answer is choice B. Okay, let's do problem number 2. Problem number 2 says an equation is given, then we have to find find the value of xy. Okay, so the equation is given 2 by 3 multiplied by minus 4 by 5 plus 9 by 11 is equal to minus 4 by 5 multiplied by multiplicative inverse of negative of x, this plus 9 by 11 into multiplicative inverse of y. Okay, then the value of xy. So basically we have to find okay, let's see, we have to do a little bit of simplification. We have to do a little bit of simplification regarding the multiplicative inverse, addition and multiplication. Now, but before doing that, please note that the left hand side is in the form this whole equation is of the form a multiplied by b plus c. The left hand side is of the form where a is 2 by 3 and b is minus 4 by 5 and c is 9 by 11, and the right hand side we can see is the right hand side is minus 4 by 5, which is b multiplied by whatever this is. This is, let's say, minus x, multiplicative inverse of minus x, plus 9 by 11. 9 by 11 is c into, we have minus y. Now if you see on the right hand side, on both sides of the equality, basically it is a kind of distributive law of multiplication over addition has been applied, it seems, because now on the right hand side, what I have written in terms of a, b and c is I have written the same equation given where a is 2 by 3 and b is minus 4 by 5 and c is 9 by 11. Okay, now, okay, so but we know, okay, so we have this. If I consider, let's say, if I consider 2 by 3 equals to a, minus 4 by 5 equals to b, and 9 by 11 equals to c, then in the given equation on the left hand side is nothing but a into b plus c, which should be, if I apply the distributive law of multiplication or addition, it should be a multiplied by b plus a multiplied by c. Now, but as per the right hand side of the given equation, it is b multiplied by minus x multiplicative inverse of minus x and plus c into multiplicative inverse of y or reciprocal of y. Now, if you now if you compare, so definitely this thing has to be equal to this thing. Now if you compare these two expressions, both are addition of two rational numbers, and the first term the first term is a into b, and in this the second term is b into multiplicative inverse of minus x. So this implies from let me try to write it with clearly. Okay, so if you compare these two are equal. These two are, the boxed expressions are equal, because a into b plus c, if I apply the distributive law of multiplication or addition, becomes a into b plus a into c. But a into b plus c, I have identified as, you can see, is b into b multiplied by multiplicative inverse of minus x plus c into c multiplied by multiplicative inverse of y, as I have explained on the right hand side. So the expressions inside the two boxes are equal. Now, if we compare the two terms, uh, clearly we can say that a into b should be equal to b multiplied by minus x, and we should have a multiplied by c is equal to c into y to the power minus 1. Now, this implies from this fact, from this, sorry for my clumsy solution, but I hope you are getting the point, getting the concept how I am solving it. From this we get, clearly we can say that a is equal to minus x multiplicative inverse of minus x, or reciprocal of minus x. Now, a we have seen, a we know is 2 by 3 as per the given equation. So the reciprocal of minus x is 2 by 3. So this implies minus x will be equal to 2 by 3 reciprocal of 2 by 3. Now you must know, you must understand that if the reciprocal of a number, that is a, reciprocal of a, if it is given as b, this implies that a is equal to reciprocal of b. If it is given that, so you must understand this, the reciprocal of a, if it is equal to b, then a is nothing but the reciprocal of b. Okay, so minus x I can say is reciprocal of 2 by 3, which is nothing but 3 by 2. This implies x is minus 3 by 2. If minus x is 3 by 2, then definitely x is minus 3 by 2. And also from this we get, this implies that a, why a, it should not be a into c equals plus a into c, a into b plus c is equal to, this is b multiplied by whatever this is, minus x, reciprocal of minus x, plus 9 by 11 is c, into y inverse. Okay, so also we see that from a multiplied by c is equal to c multiplied by y inverse, we get that a, with this implies that a has to be equal to y, a reciprocal of y. Now we know that a is equal to 2 by 3. So this implies that reciprocal of y is equal to 2 by 3. This implies y is equal to reciprocal of 2 by 3, which is equal to 3 by 2. So we got y is equal to 3 by 2. So we got x equals to minus 3 by 2 and y is equal to 3 by 2. This implies xy is equal to minus 3 by 2 multiplied by 3 by 2, which is equal to minus 9 by 4. So the correct choice is D. So the correct choice is D. Okay. Let's solve problem number 3. Problem number 3 says 2 by 3 of multiplicative inverse of a non-zero rational number equals 3 by 8 of the number. Find the number. 2 by 3 of multiplicative inverse of a non-zero rational number equals 3 by 8 of the number. So let the rational number be x. So this implies 2 by 3 of multiplicative inverse of a non-zero number rational number. So multiplicative inverse of x, that is x reciprocal of x, equals 3 by 8 of the number, that is x. This is given. This is the mathematical translation of the problem statement. This implies, we know that of operator means multiplication. 2 by 3 multiplied by reciprocal of x is equal to 3 by 8 multiplied by x. This implies reciprocal of x is nothing but 1 by x is equal to 3x by 8. This implies we have got 2 by 3x is equal to 3x by 8. Now if we do cross multiplication, cross product, we know that if two rational numbers are equal, if we do two rational numbers, if we have p by q equals to r by s, we know that if we do cross product, cross multiplication, we have ps equals to qr. So we will get from this we will get, if you do cross product, we will get 2 multiplied by 8 is equal to 3x multiplied by 3x. This implies 16 is equal to 9x square. This implies x square is equal to 16 by 9. This implies x equals to square root of 16 by 9. This is equal to 4 by 3. So the answer is, correct choice is B. Okay, let's solve problem number 4. Problem number 4. Okay, so it says let x and y are two positive rational numbers. X and y are two positive rational numbers. Okay, let z equals to x plus y by 2, u equals to x plus z by 2, and v equals to z plus y by 2. Then which of the following statements is incorrect? We have to select the statement which is incorrect, not correct. U and v, first choice A is u and v lies to the opposite sides of z on the number line. U lies to the left of v, v lies to the right of y. Okay, so it is talking about all the choices are regarding which number lies to the left or right of which number. Okay, so it's better we draw the number line and try to understand the position of the numbers visually. So we have the number line, and let's say x and y are two positive rational numbers. So so this is the origin O. Let's say this is let's say x, and its value is x. Let's say this be point y representing the rational number y. So point x is representing the rational number x, and capital Y is representing the rational number y. Okay, so now what is z? Z is x plus y by 2. We know that x plus y by 2 is a rational number lying between x and y, and also please note that x plus y by 2 will lie exactly midway between x and y. So this will be z, which is equal to x plus y by 2. Let's say this be z, represented by the point z. Now what is u? U is x plus z by 2. X plus, this is z, this is x plus z by 2. So definitely u will be lie between x and z, and it will be u, small u, the value will be exactly midway, its value will be exactly midway between the point x and z. So this will be something, the point u, which is representing the rational number u, which is x plus z by 2. Now what is v? Z plus y by 2. Similarly, so v will be here, v, this is v. So we have okay, so this is the scenario of the regarding the position of the rational numbers z, u, v, x and z. Now which of the following statement is incorrect? Let's see what is A saying. A is saying u and v lies to the opposite sides of z on the number line, which is true. Z is here and u is here. U and v are lying on the opposite side of z. So statement A is correct. B, u lies to the left of v. U lies to the left of v. This is also correct. U is definitely lying to the z, to the left of v. Okay. What is C? V lies to the right of y. No, this is wrong. V lies to the left of y. V lies to the, definitely lies to the left of y. So now see, since we have already found the incorrect statement, so we can stop here, but let's anyway see what is D. D said z lies in between x and y. Z is x plus y by 2, and that indeed lies between x and y, because it is a property of rational numbers that between two rational numbers x and y, where x is less than y, the rational number x plus y by 2 lies between x and y. So this is also correct. So the answer is choice C. We have to select the incorrect statement. Okay, let's see problem number 5. The additive inverse of reciprocal of 1 by 7 plus 1 by 11 minus 3 lies on the number line. Okay, so let's find out what is 1 by 7 plus 1 by 11 minus 3 lies on the number line. Okay, now minus 3. Okay, to the left of 0, definitely it will lie to the left of 0. Now clearly we can see that the value of this will never be greater than 3. So and over here this is minus 3, this is minus 3. So you can consider this as equal to minus 3, this is equal to minus 3 plus 1 by 7 plus 1 by 11. Now 1 by 7 plus 1 by 11, it will never be equal to 1. Okay, so let's see, this is minus 3 plus this is 11 plus 7 by 77. This is equal to minus 3 plus 18 by 77. Now 18 by 77 is less than 1. Its value is less than 1. So definitely the whole value will be less than, it will be greater than minus 3, but less than, greater than minus 3 but less than minus 2. This 18 by now 18 by 77 is definitely less than 1. So this implies, if we have this kind of equality, that 18 by 77 is less than 1, I can add same number on both sides, any non-zero number on both sides, and the inequality will remain same. So I can add minus 3 both sides, and I see that this is less than 1 minus 3. So this implies that minus 3 plus 18 by 77 is less than minus 2. Is less than minus 2. So the choice B, we can rule out which choices are definitely not correct. Choice B is saying to the right of 0. This is definitely not correct because the rational number will be definitely less than minus 2. So choice B is incorrect. Between minus 1 and 0. Okay, between minus 1 and 0, this is also not correct because we have already seen the rational number we have expressed as minus 3 plus 18 by 77, and we have seen 18 by 77 is that 1, so we can see that minus 3 plus 18 by 77 is less than minus 2 and minus 2. So in the number line, if this is the origin, we have 0, we have minus 1, we have minus 1, here is minus 2, and the point the rational number is less than minus 2. So the rational number will be somewhere here. A is the rational number, given rational number, that is minus 3 plus 18 by 77. So it is definitely less than minus 2. So therefore the choice C is incorrect. It is saying that between minus 1 and 0. No, C is correct. C is incorrect. What about D? To the right of 5. No. To the right of 5 is definitely incorrect. So the correct choice has to be A. To the left of 0. To the left of 0. No, to the left of 0, this is yes, to the left of 0, because we have already seen B, C and D are incorrect. So the correct choice is A. The correct choice is A. Okay, let's do problem number 6. It says, which among the following is the smallest rational number? Okay, so we have to find the smallest rational number. The rational numbers as given in all the choices are minus 4 by 11, minus 13 by minus 12. Minus 13 by minus 12 is nothing but the minus will cancel out. It is 13 by 12, and we have 49 by minus 12. If you convert, make the denominator positive, it will be minus 49 by 12, and we have minus 9. It is asking the smallest rational number. Okay, the smallest rational number. So definitely it will be one of the, we have 3 negative rational numbers. Now if you try to, now what is this? This is an improper fraction, minus 49 by 12. If you convert it into mixed fraction, it will be minus 4 1 by 12. So it is minus 4, negative of the mixed fraction 4 and 1 by 12. Okay. So if you, and what is this? This is a positive rational number. It will not matter. We have to find the smallest rational number. Okay. Now, if you try to visualize the position of all these rational numbers on the number line, let's say this is the number line. So we have somewhere origin O, and definitely 13 by 12. 13 by 12. 13 by 12 is equal to 1 and 1 by 12. So it is a little greater than 1. So if this is 1, if the point A represents the integer 1, point B will be very near to A, but to the right hand side. So this will be 13 by 12. Anyway, we need not bother about the positive rational numbers. We need not bother about 13 by 12. We have to see the position of the 3 negative rational numbers. Now, minus 49 by 12 is a minus 4. Let's say this is minus 4 1 by 12. And definitely minus 4 by 11. 4 by 11 is less than 1. 4 by 11 is less than 1. So negative of 4 by 11 will be, if this is minus 1, this is minus 1, this point will be approximately minus 4 by 11. What else do we have? And 9 it will be somewhere here. So we can clearly see that the minus 9 is, the position of the minus 9 is to the leftmost. 9 is the position of 9 on the number line is to the extreme left, and all the negative numbers, two negative numbers, are lying to the right hand side of the number minus 9 on the number line. So definitely minus 9 is the smallest rational number. So the answer is D. Let's do problem number 7. The value of is equal to, so we have to simplify. Okay, the value of, it is saying that the value of minus 19 by 23 plus 1 by 4 minus 0, it will not matter, so we can skip the minus 0. This plus 2 by 3 minus 8 by 9 is equal to. Now clearly, as per the given choices, you can clearly see that we should not simplify this to a single value, rational value, because the choices are also in terms of addition and subtraction, and all the choices have the same terms that are found in the given expression. Now if you see the choice A, in this expression, if you group together the positive rational numbers and the negative rational numbers, this will be, I am grouping the negative rational numbers, that is minus 9. So this is minus 9, 19. So this is equal to nothing but I can open the brackets without any problem. I can open the brackets like this, plus 1 by 4, and this bracket will also open without any changes in the sign of the rational number inside, because before the bracket there is positive sign. So this will be 2 by 3 and minus 8 by 9. Now what is this actually? This is minus 9 by 23 plus 1 by 4 plus 2 by 3 plus minus 8 by 9. So we have some addition of 4 rational numbers where 2 are negative. If you group the negative rational numbers together and the positive rational numbers together, we get 1 by 4 plus 2 by 3, and then I have minus 19 by 23 plus minus 8 by 9. Now this definitely matches with the choice A, but you can see a little bit of difference. In the choice A, the term which is being subtracted is are 19 by 23 and 8 by 9. But in our result, what we are having addition of two terms, this plus this, but the choice A is a subtraction of two expressions. Now you can I hope you will understand that this is equal to minus 19 by 23. I can minus 19 by okay, so we have this now. Okay, so we got this, fine. Now this result that we got will clearly match with the choice A, and now why, before that, why it will choice with match A, let's try to find out why the choices B and C are not applicable, they are incorrect. Now we have this. Now in the choice B, you can clearly see Okay. Now what is choice B? In the choice B, it is okay. Let's not instead of grouping the negative and the positive rational numbers, let's have this. So we have this, the addition of four rational numbers. Now let's try to open up all the, for all the choices. Let's see the verify the each choice one by one. Now, and we will while verifying the choices, we will open up all the brackets. So we have the choice A is given as 1 by 4 plus 2 by 3 minus 19 by 23 plus 8 by 9. Now I hope you will agree that this is equal to this minus 19 by 23 minus 8 by 9. I hope this need not require any kind of justification or clarification. Why? When I open the brackets, so the justification is that when I, for the second term, that is this term, when I open the brackets, when I open the second brackets, the sign of the two internal rational numbers will change because we have a negative sign in before the bracket. So that's why 19 by 23, it's better to write like this. When we open the brackets, this will be the rational numbers inside the bracket. The sign will change because before the bracket we have a minus sign. So this will be minus 19 by 23 plus minus 8 by 9. Now you see choice A, the results, the four rational numbers, addition of four rational numbers are same as what we got. This is what we got from the given expression. From the given expression we got this. This is the addition of four rational numbers, and the choice A, whatever if you open the brackets, we get this. So this is clearly equal to what we got. So we have the terms 1 by 4, 2 by 3, minus 19 by 23 and the minus 8 by 9. The similar rational numbers we have got, we have in the result. So A is correct. The value of the given expression is definitely is equal to the value given as choice A. So A is a correct choice. Now what is B? If B, if I open up the brackets, I will have minus 8 by 9 plus 1 by 4, and the second bracket, if I open it, since it has a negative sign before the bracket, the rational numbers inside will change their sign. So this will be minus 19 by 23 plus minus 2 by 3, its sign will change, so it will become 2 by 3. So this is also same as this. So this is also same as this, equal to, so this is also same. Sorry for my very weird way of explanation, but I hope you are getting the point. This is also equal. So we can see choice A and B both are correct. And let's see what is C. If I open up the brackets of the given expression in choice C, the first bracket will open, but the rational numbers inside will change their sign because we have a negative sign before. So it will be minus 8 by 9, and we have inside minus 2 by 3, which is nothing but, so what is this? Now you need to understand this. We have minus 8 by 9 minus 2 by 3, that which means plus minus 2 by 3. Because we know subtraction of two rational numbers, we know that if x and y are two rational numbers, then x minus y is nothing but x plus additive inverse of y, that is minus y. So now if you open the brackets, this one, this will be minus 8 by 9 plus the additive inverse of minus 2 by 3, which is 2 by 3. So we have plus 2 by 3, and the second bracket in the choice C will open as it is, because we have positive plus sign in before the brackets. But remember that minus 19 by 23 is nothing but plus additive inverse of 19 by 23, which is minus 19 by 23. Now clearly this is also equal to this. So both choices A, B, C are correct. That is, the value of the given expression is equal to the value of the expression given in choice A, B and C. So hence the correct choice is answer D, that is all of this. The correct choice is answer D. Okay, let's do problem number 8. It is saying the position of which of the following rational numbers and its reciprocals remain the same on the number line. The position of which of the following rational numbers and its reciprocals remain the same on the number line. That is, it is saying indirectly that which of the numbers in the given choices the number is equal to its reciprocals. So choice A, we see that the reciprocal of A, that is multiplicative inverse of minus 1 of 1, is nothing but 1 only. We know that. So we know, we have already studied that, discussed in the previous videos, in the theory video, that 1 and minus 1 are the only two rational numbers which are equal to their multiplicative inverse. So reciprocal or multiplicative inverse of 1 by 1 is nothing but is equal to 1. How? Because 1 by 1 is equal to 1 by 1, and its multiplicative, when we do its multiplicative inverse, we just reverse the numerator and the denominator, and we can see the numerator and the denominator both are 1. So this remains 1 by 1. This is equal to 1. So 1 is definitely is equal to its reciprocal. Now it is saying that the position of which of the following rational numbers and its reciprocals remain the same. That means that the reciprocal and the number are same. So A is a choice, is a correct choice. Now B, we also know that reciprocal of minus 1 is nothing but, we know that minus 1 is minus 1 by 1. Its reciprocal will be equal to 1 by minus 1. This is equal to minus 1. So the correct choice is C, both A and B. Its correct choice is C. Let's do problem number 9. Find the value of, okay, some complex expression. Find the value of, okay. So it is 2 and 1/3 minus 1 2 by 11 divided by, we have 3 plus 1 by again 3 plus again 1 by 3. How many 3's? We got 3. Okay. So 3 plus 1 by 3. So there seems to be a pattern in the denominator. We have 3 plus 1 by again 3 plus 1 by 3 plus 3. Now I am not aware of any kind of trick that might be used to solve this problem, but in my experience, what I will first do is that 13 by 11. So what is this? What is the value of this? This value is 10 by 3. 3 plus 1 by 3 is 10 by 3. Okay. So I would like not, maybe there is some trick might work, but I'm not, no such trick is coming, at least in my mind. So I would like to solve it in a very straightforward way, using the concept of reciprocal or addition and subtraction of rational numbers. Now in the numerator, let's first convert the mixed fraction to improper fraction. So this becomes 2 and 1/3 is 7 by 3 minus 1 and 2 by 11 is 13 by 11. This divided by, we have 3 plus 1 by 3 plus we have 1 by 10 by 3, because 3 plus 1 by 3 is 10 by 3. Okay. So this is equal to, now let's find out, simplify the numerator. So we have 77 minus 39 by 33 divided by, let's do some further simplification of the denominator. 3 plus, we have 1 by 3 plus 1 by 10 by 3. What is 1 by x? 1 by x nothing but reciprocal of x. So 1 by x by y is nothing but is equal to reciprocal of x by y, which is y by x. So the reciprocal of reciprocal of 10 by 3 is 1 by 10 by 3, which is equal to 3 by 10. Okay, so we have this. Now if we further simplify this, the numerator becomes 8 and 4 3 38 by 33 divided by, we have 3 plus 1 by 3 plus 10 3 plus 3 by 10 is 33 by 10. 3 plus 3 by 10 is 33 by 10. So this is equal to 38 by 33 divided by 3 plus 1 by 33 by 10 means the reciprocal of 33 by 10, which is 10 by 33. So this is equal to 38 by 33. Now if we simplify, 3 plus 10 by 3, that is 99. 99 plus 10, that is 100 by 33. Okay, so we have 38 by 33 divided by 100 by 33. This is nothing but 38 by 33 multiplied by the reciprocal of 100 by 33, that is 33 by 100. So 33 cancels out, we have 38 by 100. 38 by 100 is the answer, and we do not have 38 by 100 as a choice. We have 38 by 109. How come 109? 3 plus 10 by 99 plus 10. Oh, sorry. This will be not 100 but 109. Sorry, 109. 109. Okay. So the correct choice is A. Okay, let's do problem number 10. Problem number 10 says that if some equation is given, on the right hand side we have some term x. Okay, so what is given? Let's write it down. We have 15 and 2 by 3 multiplied by 3 and 1 by 6 plus 6 and 1 by 3rd, 6 and 1 is equal to 11, 7 by 8 plus x. Then find the value of x. This is a kind of linear equation in one variable x, but the terms are mixed fractions. So you have to convert. Now whenever you doing solve this kind of problem, whenever you have a mixed fraction like 6 and 1/3 as addition or subtraction, do not immediately convert it into an improper fraction. Always try to see whether if you are given a mixed fraction like a and b by c, do not immediately convert this as ac plus b by c. Do not convert it as a rational number. Always try to see that the mixed fraction a and b by c is also equal to a plus b by c. Also try to see if this thing is helping in solving the problem or not. In this problem I think it will help. But anyway, so let's on the left hand side, the first term is a multiplication or product of two rational numbers. We have to do that anyway. So we have to convert the mixed fraction to improper fractions. So 15 and 2 by 3 is 47 by 3 multiplied by 3 and 1 by 6 is 19 by 6. Forty-five. 47, 45, 47 by 3 multiplied by 19 by 6. Okay, so plus 6 and 1/3. In the choices, all are mixed fractions. Okay, so let me write 6 and 1 by 3rd as 6 plus 1 by 3, and the right hand side also, the 11 and 7 by 8, I will write it as 11 plus 7 by 8, and we have x. Now this implies 47 by 3 multiplied by 19 by 6. This will be, I do not see any kind of cancellation is happening, so it will be, we have to do the multiplication. Uh, 47 multiplied by 19, this is 63, 63, 42, 47, that is 3, 9, 8, 893 divided by 18, plus 6 plus 1/3 is equal to 11 plus 7 by 8 plus x. This implies if you convert the 893 by 18 as in a mixed fraction, this will be 18. I want to convert 893 by 18 as a mixed fraction, so 4, 72, 713, 9, 72, 16, 1, 1. So this is equal to 893 by 18 in a mixed fraction, in the form of mixed fraction, is 49, 11 by 18. So we have plus 6 plus 1 by 3 equals 11 plus 7 by 8 plus x. So this implies now x will be equal to, now 49 and 11 by 18 is nothing but 49 plus 11 by 18, and we have plus 6 plus 1 by 3. Now x will be, if you bring all the constant terms to the left hand side, so 11 plus 7 by 8 from the right hand side, when you will bring it to the left hand side, it will become minus 11 minus 7 by 8. So now this is equal to, we have 49 plus 6, that is 54. This 49 plus 6 is 54, minus 11 is 54 minus 11 is 43. So we have 43 and plus 11 by 18 plus 1 by 3 minus 7 by 8. So this is equal to, we do not have 43. Okay, we have 44 in the choice. Okay, so 43 plus, let's find out what is this. Let's simplify this. Now what is the LCM of what is the LCM of 18, 3 and 8? 2, 9, 3, 4, 3, 3, 1, 4. So the LCM is 2 into 3 into 3 into 4, that is 6, 18, 72. And this will be 44 plus 24 minus 9, 49. So this is equal to 43 plus 68. 68 minus 44. Why it is coming 43? It should be 44. Then it can match with the choice D. 45, 47 by 3, 19 by 6, 47 into 9, 19, 63, 6, 36, 42, 47, 3, 9, 8, 893 by 18. Okay, then 823 by 18, we have 49, 11 by 18 plus 6 plus 1 by 3 equals to 11 plus 7 by 8. Minus 11 minus 8. (46 plus 6), 49 plus 6 is 55, and 55 minus 11 is 44. Oh, sorry, this is 44. This is 44. Okay, so 44 plus, and we have over here 68. 68 minus 49 by 72. This is equal to 44 plus 68 minus 49, 9, 19 by 72. 19 by 72, it should be 5. So we have 11 by 18 plus 1 by 3 minus 7 by 8. So the LCM of 18, 3 and 8 is how much? 18, 3, 8 is 72. Okay, and 18, 4, 72. So 44 plus 24 minus 49. Oh no, sorry. This is not 49. This will be 9, so 63. This is 63, this will be 63. 63, so we have this as 5. So definitely this is nothing but 44 and 5 by 72. So the correct choice is answer D. Okay, let's do problem number 11. Problem number 11 says on simplifying this we get 19 by k. Find the value of k. Okay, so let's see what do we get by simplifying. Minus 4 by 3 multiplied by 12 by minus 5 plus 3 by 7 multiplied by 21 by 15. What is this? This is equal to minus 4 by 3 is minus 4 by 3, and 12 by 15, 12 by minus 5, we have to convert that to standard form, that is make the denominator positive, so it will become multiplied by minus 12 by 5, and we have this is equal to 3 multiplied by 21 divided by 7 multiplied by 15. So this is equal to minus 4 multiplied by minus 12 divided by 3 into 5 plus we have 3 multiplied by 21 divided by 7 multiplied by 15. Now we can do some cancellation. 3, 5, 3, and over here we can see 3 cancels minus 12 with minus 4. So this becomes minus 4 into minus 4 is 16. 16 by 5 plus 3 by 5, which is equal to 9 by 19 by 5, which is given to be as 19 by k. So this implies k has to be equal to 5. So the correct choice is A. Let's do problem number 12. Which of the following is not a rational number between 9 by minus 23 and minus 7 by 9? Which of the following is not a rational number between is not a rational number between. Now any number which is not a rational number in between minus 9, 9 by, okay, so the given rational numbers are 9 by minus 23, which is nothing but 9 by minus 9 by 23, and it is given minus 7 by 9. Now if you if we convert these to rational numbers to have a common denominator, we will as the LCM of the denominators, this will be minus 9 multiplied by 9 divided by 23 into 9, and this is minus 7 multiplied by 23 divided by 23 by 9. So we are converting these two rational numbers to the equivalent form to have a common denominator, which will be the LCM of 23 and 9. So this is minus 81 by 207, and this is 21 16 minus 161 by 201. So these are the two numbers, and we have to find choice the number which is not lying between these two. Now which of the following is not a rational number between 9 by minus 23? Now minus 81 by 207 is larger than minus 161 by 207. Now if you visualize the number line, so these two are negative rational numbers. Let's say this be the origin 0. So let's say this be minus 81 by 207. So the number minus 81 by 207 is definitely greater than minus 161 by 20. So let's say this. So somewhere here on the left hand side of the origin O, let's say that we have the rational number minus 81 by 207, and then the rational number minus 161 by 207, which is the equivalent form of minus 7 by 9, will be towards the left hand side of the number minus 81 by 207, because both are negative rational numbers and the numerator in 161 is greater. So we have this minus 161 by 207. So these are the two numbers, given two numbers. Let's say this is A and B, and we have to find from the choice the rational number which does not lie between A and B. Now the choice A, it is minus 121 by 207. Minus 121 by 207 definitely lies between these two rational numbers, because we can clearly see that minus 161 is less than minus 121, which is again less than minus 81. So A is lying between the given two rational numbers. What about B? B is minus 80 by 207. Since 80 minus 80 is greater than minus 81, this will imply minus 80 by 207 will be greater than minus 81 by 207. So this means that the rational number minus 80 by 207 is to the right hand side of the point B, and we have to find the rational number which is not lying in between A and B. So definitely B is the correct choice, because B is lying to the right hand side of the point B. So the correct choice is B. You can also check the other two choices. The C is minus 160 by 207, and minus 160 is minus 160 lies between minus 161 and minus 81. So definitely it also lies between A and B. And what is D? D is minus 306 by 414. Now what is D? D is nothing but the choice D is minus 306 by 414. Now you can see that it is not in standard form. You can reduce this further by dividing with 2. If you divide both the numerator and the denominator by 2, we get minus 153 by 207. So the rational number in choice D is minus 153 by 207, which definitely lies between the point A and B, as minus 153, as we can clearly see that minus 153 lies between minus 161 and minus 81. So the answer is B, that is minus 80 by 207 does not lie between the points between the given two rational numbers. Okay, let's do problem number 13. The average of the middle two rational numbers, if 4 by 7, 1/3, 2 by 5 and 5 by 9 are arranged in ascending order, is. the average of the middle two rational numbers if 4 by 7, 1 by 3, 2 by 5 and 5 by 9 are arranged in ascending order. So if the four rational numbers are arranged in ascending order, the middle two, the average of the middle two will be, okay. So in all the choices we can see the denominators are either 45 or 90. Now so we have let's say the rational numbers are, let's say, x, y, z and u, which in this problem are 4 by 7, 1/3, 2 by 5 and 5 by 9. Now whatever be the final order of these rational numbers in ascending order, the sum of the middle two, let's say the sum of the middle two has to be their sum divided by 2. Now, and the middle two has to be any two of the given rational numbers. Now let's say I am without finding what the actual ascending order will be, let's say if can 4 by 7 and 1 by 3 be the middle two terms, we can be the middle two terms, because if these are the two middle two terms, this will imply their average will be 4 by 7 plus 1 by 3 by 2, which will be equal to 12 plus 7 by 21 by 2. This is equal to 19 by 42. But in all the choices, the denominators are either 45 and 90. So the trick is you have to choose, you have to find which two rational numbers. Anyway, the middle two terms will have to be among these four rational numbers. So find the two rational numbers whose average, if you do find, the denominator can be either 45 or 90. So 4 by 7 and 1 by 3 is not a choice. I am having the denominator, their average is having the rational number of their average is having the denominator as 42. Now can 4 by 7 or 2 by 5, can it be 4 by 7 and 2 by 5? I don't think so, because if I add 4 by 7 plus 2 by 5, I will get the denominator 35, and their average, then the average will be, so let's say if these two are the two middle terms, then their average is 4 by 7 plus 2 by 5 by 2, which is equal to 20 plus 14 by 35 by 2, which is equal to 34 by 70. We are having 70. So this 4 by 7 and 2 by 5 cannot be the two middle terms. Now can it be the only, now you need not consider all the pairs. You can easily see that 2 by 5 and 5 by 9, if you add them, the denominator becomes 45 and their average will obviously become 90. So 2 by 5 and 5 by 9 can be a choice. It may not be the choice, it can be a choice. Now what else? 1 by 3, 5 by 9, it cannot be a choice. What else? How can we get 90 in the denominator? That is the average of the two middle terms. Can we get 90 in the denominator? 90. So 90 means 45 into 2. So we need to have 45 in the sum of two terms. Can we have 45? Yes, we can have 90. So if you notice, observe, the only possibility of the average of the two rational numbers whose denominator can be 90 or 45 is 2 by 5 and 5 by 9. So now you see what is the average of 2 by 5 and 5 by 9. This is the average. If you simplify this, this is 18 plus 25 divided by 45 by 2. This is 43 by 45 by 2. This is equal to 43 by 90. So definitely the choice is answer. The correct choice is D. Okay, so this problem you need to solve without actually sorting the given four rational numbers in ascending order. Just by seeing the choices, just by seeing the denominator, because you know whatever the middle terms will be, let's say if it is x plus y, then the average will ultimately be x plus y by 2. Now you have to judiciously, wisely check which two terms you can select whose average, if you do, the denominator can be 45 and 90 or 90. So in this way you can wisely select the two terms and check. Okay, so let's do problem number 14. Problem number 14 says that in the above number line, so we see a number line, O is the origin, and we see P is representing the integer 3. So this is the number line. We have the origin O representing the integer 0. We see a point P representing the integer 3, and we can see that we have point Q, R and S. Okay, it is given that OQ is equal to QR is equal to RS is equal to SP. Okay, so all these distances, so basically the points QR is are marked at equal distances from each other. That is, the distance between O and Q is equal to distance between Q and R. It is equal to the distance between R and S is equal to the distance between S and P. So we can see that OP is divided. We can see OP is divided into how many equal parts? 1, 2, 3, 4 into 4 equal parts. That is, this implies that OQ equals to QR equals to RS equals to SP is equal to OP divided by 4. This is equal to OP is 3 by 4. Now what is saying, in the above number line, if this, then what rational numbers are being represented by points Q, R and S. Okay, so the rational number that is represented by point Q is nothing but the value of the distance between O and Q. So clearly OQ is, since OQ is 3 by 4, the rational number Q will represent the point P, the point Q will represent the rational number 3 by 4. Q must represent the rational number 3 by 4. Now in the choice, we see that in the two choices B and C, it has given 3 by 4. Okay, so let's find out what will point R represent. For that we need to know what is OR. OR is definitely equal to OQ plus QR, and we know that OQ is equal to QR. So this is twice of OQ. This is equal to 2 into 3 by 4, which is equal to 3 by 2. So definitely R must represent the rational number 3 by 2, and from this we can clearly say the correct choice is B. Correct choice is B. Okay, let's do problem number 15. Simplify. Okay, so we have to simplify. It is 13 and half minus, we have the bracket 4 and half minus, we have again bracket 3 minus, we have again bracket 2 minus half, bracket closed, bracket closed, bracket closed. So you must be familiar with Bodmer's rule. Bodmer's rule, which says about the order in which you must apply the brackets. And what is O? D is for division. You must apply first the brackets, that is evaluate, simplify the expression inside the bracket, and then division, then perform division operation, then multiplication operation, then addition and subtraction. But what is O? What is O? I always forget O. What is O? Let me see if I can find what is O. What is O? Number systems. What is factors? O is off operator. Sorry, O is off operator. So B for brackets, all the three brackets, any brackets, and the brackets you must open the brackets from inside out. That you first simplify the innermost brackets, and then you work outwards. Innermost, then the second innermost, then the second innermost. This way you open the brackets, and O is the off operator. Okay, so this is equal to, let's for all the mixed fractions you first convert it into improper fractions. So 13 and half is 27 by 2. Okay, let's first do it this way. I am converting all the mixed fractions to improper fractions. Now 4 and a half is 9 by 2 minus we have 3 minus, I have to operate first this, I have to simplify, I have to first simplify the value inside this bracket. So this is the innermost bracket. So 2 minus half is 4 minus 1 by 2, that is 3 by 2. So I have 3 by 2. Now I will simplify this bracket. So this is equal to 27 by 2 minus, bracket open, 9 by 2 minus, now what is 3 minus 3 by 2? That is 3 by 2. That is 3 by 2. So finally I will open this bracket. This is 27 by 2 minus 6 by 2. So this is nothing but 27 minus 6 by 2. This is 21 by 2. Now all the options are given as mixed fractions. So if you convert 21 by 2 as mixed fractions, this becomes 10 and half. 10 and half. So the correct choice is B. Now I was thinking to solve this problem in another way. Instead of converting the mixed fractions to improper fractions, I was thinking, what if I would write 13 and half as 13 plus half, and so I will separate out the whole parts and the fraction parts of all the mixed fractions and do the simplification. But I don't think it will help much. This was a pretty simple problem. It was not too much complicated. So for this problem, I don't think it will help if you separate out the fraction part and the whole part of the mixed fractions. So anyway, this brings to an end of solving the sample test paper 2. I hope this video was beneficial in understanding how to apply the concepts of rational numbers to solve these kind of problems. These problems are comparatively harder than the problems we have solved from the textbook of author R.S. Aggarwal. So if this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So with this we come to an end of the first chapter, that is rational numbers. I will tomorrow start the next chapter, that is exponents, but parallelly I will start the series of videos on concepts to remember in a separate playlist which will be named Concepts to Remember Maths Maths 8, where I will discuss about the key, very key concepts, formulas, or any possible tricks, and all the variants of problems that you need to consider for a particular chapter. So it will not be a one video, it will be over multiple videos, topic wise, and each video there will be some associated sample problems based on based on the concepts that I will discuss in that particular video. So please stay tuned for those videos, and chapter wise, theory wise, the next video will be on the next chapter, that is exponents. So thanks for watching, and until the next video, take care and bye.